Good morning, namaskar to everybody. Uh, as discussed just now about the role of satellite data, and just we have been very well seeing our Dr. Kiswal Saab presentation. After that, just I will try to give some brief of how in operational weather forecasting we are utilizing the satellite data. So basically, it is a role of satellite data in for weather and forecasting. Uh, Before I start, just I would like to give you what are the natural hazards in India. First, if you can see this particular slide, we have been number of weather hazards in India throughout the year. Let's say the drought, forest fire, earthquake, flood, heat waves, particularly heat waves and cold wave. The area, the same area, the different season. Thunderstorm, most part of the area we have been experiencing the thunderstorm. Heavy rainfall and flash floods, cyclones, particularly two seasons, and that is also almost 7,500 kilometers long. And then landslide, particularly over the Himalayan region, that is the Himalaya and Western Ghats. Mostly rainfall, particularly induced for 6 to 7 major landslide events each monsoon. So these are the number of natural hazards. It is basically we can say the area where we are completely data sparse region. Why? Because it is due to the Great Himalayas to the north, Bay of Bengal to the east, Arabian Sea to the west, and Indian Ocean to the south. So basically, if we can see, so most of the natural hazards are basically season dependent. If you can see here in this particular slide, like in a winter month that we are calling the January, February, western disturbance, cold wave, fog, particularly if I can say heat, heavy snow, frost, and then pre-monsoon season we have started from the March to May. Cyclonic disturbance started, heat waves, thunders, storms, squalls, hailstorm, and then we are going with the monsoon, June, July, August, September, heavy rainfall, floods, drought, and then post-monsoon season, so October, December, like cyclonic disturbance, northeast monsoon, heavy rainfall. So all the natural hazards now being assigned to the particular season, and accordingly weather events are being happening. Now, if we see how they are affecting to the our country, if we next. So this weather system, how this weather system affecting the India? So our country is affecting by, as I mentioned, with the season, and now the number of weather events which is occurring over the Indian subcontinent, and they're affecting our weather pattern. Like if you can see over the north region, this is it is given by the western disturbance, and slightly if you go to the IGP, that is a Indo-Gangetic plain, it is mostly thunderstorm and fog. And if you go to the northeast region, that is also thunderstorm. And then if you come down over the Bay of Bengal, you will be finding out the monsoon low, and then cyclone, particularly over the Bay of Bengal. And if you go to the west, you will finding out the offshore vortices, and then cyclone, and now we are generating over the Arabian Sea because of it's warmer. And then you can say the monsoon low, mid-tropospheric cyclone, thunderstorm, onset vortex. All these things has been affecting India in terms of weather. And basically, if you can see from my IMD's point of view, the basic meteorological observations and forecasts for optimum operation of weather sensitivity activities, IMD is a self-reliant India, particularly for giving the accurate and rendering the good weather forecast. So accurate warning against hazards and reasonable lead to leading to the response from disaster managers and public to the save life. If you can see the table, you'll be finding out number of observations have been taking role of to the users, particularly the forecaster and the different stakeholders. So improvement. Problem. Yes. So if you can, by large, if you can see the what are the tasks that what IMD is doing, that improvement in the economy in the sectorial application. Now with this meteorological observation, different sort of sectors like environment, power grid, highway, non-conventional energy, satellite, defense, med support for floods, petroleum, tourism, sustainable urban development, agriculture, shipping. So all these things have been very well taken care by our the observation. And basically, how this observation comes, how this observation can be give us the policy decision for the weather forecast. That is the most important for us. So for that number of observations, not only from in situ, from the space also we are looking up to, and that help us to give or render the accurate weather forecast. Now, if I go to background, the past decade has witnessed the significant improvement in the field of numerical weather prediction, the development of sophisticated model. But this development of the model also give us the demand. They put on the demand that high spatial and temporal resolution surface observation as input to the NWP models and coverage over the land, and virtually non-existent over the vast oceanic region. As I mentioned in my initial 2-3 slides, that those are the regions where data sparse region, like Himalayas, West Bay of Bengal, Arabian Sea. Those are the completely, you can say, one sort of data sparse region where we could not have the much data on a regular interval what we require. So the measurement of the atmospheric components from space, particularly from the geostationary platform, these offer us to repeatedly a regular measurement over a wide area as well as over the area not accessible by the conventional method. So that have given us the, so this measurement basically what? From the space, if we can take, there are a number of geophysical parameters such as albedo, temperature, incoming solar radiation, rain, humidity, winds. So these all products we are getting on regular interval, and these enable us to get the observation for the full disk for better than 30 minutes. Now we are getting instead 3D3DR, as Dr. Kiswal Saab has mentioned, we are getting the data every 15 minutes. So this has improved our observation capability, and that is the reason that we need a space technology. Now again, if you see the graph, why we need a space technology? For the small reason, we need an instrument, so that is the domestic synoptic data. So we have a very high confidence. But as you move on the coverage, as you know that satellite data has a very large coverage. That is like almost 1,000, 2,000 to 5,000 kilometer area, or more than 5,000, 10,000 kilometer area of spatial capacity to observe the Earth. But it also reduces the confidence. So we need to improve this confidence. How we can improve it? So we need good interpretation of satellite data. Now you can see that these are the Met satellites that is special relevance to the weather and forecasting, like INSET 3D3DR is one of the major input from the satellite we are getting. DMSP, NOAA, METOP B, C, then MODIS, TRMM, then visible IR images from polar orbiting satellite also used for cyclone analysis, Dvorak technique, intensity classification, and if you can go with this current status, there are a number of observations we are taking care from the space, particularly monsoon, cyclone, thunderstorms, vegetation, soil moisture, cloud, fog, ocean, land, atmospheric observations. And then the most important thing for us to provide this data to disseminate to the user, disseminate to the different communities. And if you can see, by the 3-4 years, we have reached today every day, we are assimilating almost 95 GB of data from satellite and 435 GB of data from the polar orbiting satellite. It was 5 years ago, it was almost 30, and it was almost 100 GB. So now the capacity to assimilate this data for weather forecast, satellite data is most important, and the voluminous data from the satellite help us to predict the good weather. So that is the most important, because it also helps us to defining the initial condition of the Earth and ocean and atmosphere. And then final, if you can see the graph, that's a dissemination, which is the most important. Once you compile your data, you need to disseminate it. So that part is also most important as far as your dissemination is concerned, because once you prepare your weather, you need to disseminate it to the timely manner. Now instead 3D3DR, I'm not going to the deep. The major statement I can make it that there is a paradigm shift in observation from the space while introducing INSET 3D3DR in our weather forecasting. The reason, the two most important channel is that MIR and SWIR channel. I will explain you, and you can also, it will be very well visible to you how these two channels help us to give accurate forecast as far as nowcasting is concerned, severe weather is concerned. Now, I'm from the Satellite Meteorology Division, as Madam has explained. Basically, the Satellite Meteorology Division started from 1972 to 82, and we received the data firstly from the NOAA, and then complete series you can see that how the path has been from the satellite era has been started, and now we reached to the almost 2021 with 3D, 3DR, and now 3DS, and GISAT is also about to launch. Now, what are those products which is helping us from weather application side? Now, these are the products that like outgoing long wave radiation, atmospheric motion wind, cloud mass, smoke, CTT, that is cloud top temperature, land surface temperature. So these are the number of products we are generating from the INSET 3D, 3DR, and which and you can see the number of parameters in terms of sounder. It is a temperature profile. It is basically geopotential height, humidity profile. That is a layer precipitable water index. They also give us the inference initially that what could be the weather and what could be the weather in based of the middle to upper level of the atmosphere, and that is comes from the point of T5 ground. All the weather analysis are making use of this T5 ground from the satellite, and we have a number of observations in the entire country. That is our med centers. We are defining this T5 ground, which gives us the level of condensation (LCL), level of convective activity from where it starts. So these all comprises, and then finally we have a number of stakeholders. Same for Mata Vaishno Devi, for Amarnath Yatra, Char Dham Yatra, aviation sector. So these are the number of sectors which basically being rendered with our observation, and we are rendering with the in terms of our weather application bulletins and all. Now I'll come to the important point, that why satellite data monitoring is important for the weather. Because as I mentioned that NWP has increased. Yes, NWP utilization has been increased. But again, in correctly forecasting convective initiation, there is some gap. Gap means the NWP model scenario will give you what could happen in next 1 to 5 days or 6 days. But where satellite imagery is the most important for the severe weather, that what is happening. So if I can combine it for smaller and scale of convection as dissolved in radar, the motion of the scene from the satellite very well. So if you play the animation from the satellite imagery, it will give you the very good information about how the weather has been passing on. Now, what are the basic principles of satellite imagery? What you look into? So there are 6 basic characteristics which we are seeing in IMD. That what is the one image that you are seeing from whether IR and visible. We need to see the brightness. How cloud is imagery is one of the best indicator determining its thickness. Second is texture. What kind of texture it is, what is the spatial arrangement of the element is there, what degree of smoothness is there, and whether it is opaque or motile, or what kind of it can be seen in a visible imagery. And then shape, that is also most important, shape and form of the elements. So individual cloud element can assume a variety of shape, like round, straight, scattered, diffuse, or curved. So these are the kind of characteristics we are identifying in a cloud, particularly in the satellite imageries. So and the fourth one is the pattern. That is the cloud system on satellite imagery. How it will be recognizable, like linear, cellular, circular, banded, comma. So which is most important, because during the cyclone we need to see what kind of pattern it is behaving. Because in cyclone there are number of stages are there, right from your depression to your very severe cyclone to extreme severe cyclone. So this pattern is the most important. And then your size, what kind of size it is. It's a eye is if we are looking at what is the size of the eye, what is the eye wall of the, what is the size of the eye walls. So this the 5th one, and the 6th one, what is the vertical structure. So this information of vertical structure is also very important. It can be obtained through satellite imagery in form of CTT. So what basically SOP we are following. First, we are seeing the continuity in the time has to maintain. The picture shouldn't be viewed in isolation, but must be interpreted with reference to past weather. See, if you are seeing the imagery at 3 UTC, you need to see your second 2 UTC, 0 UTC, and then last night what had happened. As we have seen in the past presentation, that over the India weather, if you want to know, you want to see the Pakistan and Afghanistan, particularly for the western disturbance kind of a weather. So you have to be very, you could not see any image in isolation mode. You have to past weather, earlier imageries, that also need to be kept in your mind, and your seasonal and your local topography and the similarity in a different season, like summer season you are seeing imagery and winter season, both have a different meaning in the northern and southern hemisphere. And the local feature is also very important, like mountains and valley, because those have also played a very important role. Like in this imagery, if you can see how we are defining the clouds from the satellite imageries. Like high level cloud we are determining from the 400 HP, particularly the cirrus cloud. cirrostratus, cirrocumulus, and alveolus. And then middle level 400 to 600, altocumulus, altostratus. And then low level cloud 600, cumulus and stratus. So basically, from the imagery, we are trying to find out these specification or characteristics of the cloud. Like cumulus cloud, if I can show you, if you can see the cumulus cloud from the visible imagery, as you have seen, the meteorological satellite is basically the three things: IR, visible, and microwave. So IR visible plays almost 90% of the role for the geostationary prospect and weather applications. So visible imagery, if you can see, large individual elements and group of the broken scattered cumulus appear as a bright white blobs. So on the other hand, small individual elements of the cumulus cloud are also seen in a gray area. Whereas in IR imagery, cumulus cloud covering a large area can be only seen as a dark gray. So that we have to be all weather enthusiasts, or you can say weather forecaster or application user, need to understand the satellite imagery. Cumulonimbus cloud. This is the most important sort of cloud for vertical growth of the cloud, because it gives you the thunderstorm, and sometimes it gives the very hazardous lightning and heavy rain also. So need to understand in visible imagery appears very white cloud with a very bright top. So overshooting top of sort of things you can see from these imageries. And IR also, it appears very bright and all. Now stratus cloud on fog. So stratus cloud will be look like, from the visible imagery, it is a thick stratus or dense fog, appears to have a uniform bright tone. And then from IR imagery, if you can see, it will be also difficult to detect IR imagery because the temperature contrast is very low. That is the reason, because low cloud we cannot detect from the IR. So if you go to any further weather forecaster that at the morning 10 o'clock you are coming to the office, you would like to see the weather, what channel you will be seeing? First, you will be seeing the visible channel, because it gives you the information about the low stratus cloud. And that is the most important during the winter month, because in winter, you need to look at the fog, your status, your low cloud. But in IR imagery, it is sometimes it is very difficult to analyze. Similar case on the stratocumulus. I'm not going to the deep because there are a lot of other very good things which I would like to show you. Similarly, for altocumulus, the altocumulus visible, if the size of the individual element is smaller than the pixel, then the gap between the patches are lost. So you need to locate, and you need to link your clouds to the pattern of the chart what you are seeing from the weather analysis. And that is a cirrus cloud. That is also very important, because in visible imagery, cirrus cloud is difficult to detect due to visual contamination. Where brightness, if you can see, normally a darker or translucent appearance, because it is sometimes very give you the cirrus is a very notorious cloud, you can say. Sometimes cirrus is having a water liquid, water bodies, some water contents, but sometimes it not. So this also need to be understand from the visible and IR images. This is a table which classified that if you are seeing the cirrus cloud, what color will be look alike. So and this is I'm giving you now how we are giving a severe weather forecasting. There are a number of products which just I have now mentioned, that hydro estimator, rainfall from satellite. If it goes more than 15 millimeter per hour, we are going for severe weather. If cloud top temperatures is going more than 220 to 255, it maybe go to the severe weather. If OLR values are getting less than 150 to 160, then it is a severe weather. And BT, that is the brightness temperature of SWIR TIR channel from the RGB if you play on, and then animation, definitely your severe weather will be captured very well. That is why I'm saying here, the last 5 years, there is a paradigm shift in the weather observation. I'll give you like OLR values. If you see, deep convective clouds are usually identified by their cold cloud tops, which emits low value of outgoing long wave radiation. So low values always give you the deep convective status. Now again, I'm saying that, so at what time and what season you are looking at. So like if you can see Andaman and your Lakshadweep area, you are deep convective. This is the particularly month of where onset of monsoon is supposed to announce. So this helps us for this onset of monsoon over Kerala. So deep convective clouds is being getting developed. Now this time, if you can see, it is getting developed. I think tomorrow or day after tomorrow, I think on 3rd, it is IMD has predicted the onset of monsoon will be declared on the Kerala. So these are the satellite inputs. Basically, give us the you can say the first inference from how weather could be. Similarly, this is the cloud top values. This is the CTT values, how it will be look alike, like right from your entire that area that is a northern limit of monsoons, how it will be look at, and then how CTT will be defined. Like if the cloud top is a 220K and less, then very deep convective cloud, 220 and 235 deep convective. So these are the kind of way of how we are treating the particular cloud pixel with their temperature, and we are analyzing with our weather events. Now this is one of the most important thing we devised in satellite meteorology division in 4 and 5 years ago. That is the inception of RGBs, because as I mentioned that INSET 3D 3DRS give us the lot of it offers us a lot of facility, particularly MIR SWIR channel. Through that we are merging it and we are producing one image that is called RGB. This RGB is a multispectral red, green, blue composite. They are qualitative and false color image, and now we are able to see the low cloud image, low cloud, fog, fire, and particularly cloud phase, volcanic dust, convection, so many more things. The advantage you can say that this is ability to look a single image and identify the many more weather phenomena. I'll show you. And this device we have, this particular algorithm, we fine tune here at SatMed division accordingly, because it is initially in the year 2000 it was from UMETSAT RGB. We gone, and then Siviri instrument, it has been operational since almost 10 years ago. Now we are in SET 3D 3DR. We devise with our fine tune we have done. Although our channels are one or two channels are missing, but still we made it, and we made it in the terms of day microphysics and night microphysics. So these are the science part. If you can see, visible basically give the reflectance in red beam, SWIR give you the solar reflectance in green beam, and IR give you the brightness temperature for the blue beam. So it's useful for the cloud analysis, convections, fog, snow, fires, and in this color scheme, water clouds that do not precipitate appears white. So this is a very, very important for a weather forecaster, that how they will look out. Now this is a very, very important imagery you can link with. See, in one imagery you are seeing number of weather events that right from your Indian Ocean, mature CV cell you are seeing, because this color represents the particular weather phenomena based on its temperature, based on its spectral behavior of that particular channel. Now flow of dust, you can see the flow of dust from your Arabia to it is coming to the Rajasthan area, mid-level orographic clouds, low clouds, snow appear as a pink, western disturbance, low and mid orographic clouds, cirrus clouds. So all the observation now you are looking at it into one image. Earlier it was visible IR and all. Now this is also one of the best image you can relate it in the month of February, where snowfall is also there, that has been captured. High cloud can be seen, and then your low cloud can be seen. And entire area, if you see, it is making shape of 9. So 9 shape is basically represent the weather phenomena that called the western disturbance. This western disturbance carries all these things: snow, heavy rain, high cloud, low cloud. And after once it is passes on, fog will be appear. So this phenomena can be very well captured from the RGB. Now, similarly from this RGB, we are a snow and or from your JNK to your entire IGP, we are giving forecast, and then it is clearly delineating where is the fog and where is the low medium cloud. Earlier, before in 3D 3DR, we couldn't do that because we did not have the MIR and SWIR channel. So in this imagery, you can see this is a very well useful, very good, and people are demanding, particularly from the aviation and rail sector, that from which area there will be dense fog. So dense fog, there is a likely to be a halt in the rail services. Your aviation will be the disturbance, hindrance will be there. So these pictures and this information carrying the weather application part, particularly in the form of bulletins and all, will definitely is helping the aviation industry like 3-4 years very well. Now, if I come to from the research and scientific aspects of this stunning colorful imagery now we are seeing from 3D RGB, this provides critical information to the forecaster from the situational awareness and nowcasting rapidly changing weather. Now, what is that? That is it's analyzing its spectral signature, and that can be well analyzed. Now you can see where the cloud, now you can see where the snow, and now you can see where is the fog. Now if I click on some particular link, I'll explain there is a rapid, if you click on the particular those spots, you will be able to see the spectral signature, how cloud is behaving, how fog. In fog, you will be seeing that SWIR is higher than visible, whereas in the cloud and snow, visible is much higher, where the snow SWIR is very low because it is absorbed. So this spectral signature from this RGB imagery will be very well analyzed from this. If somebody images. Now, if you can see the signature of the cloud and snow, if he says, no, I would like to see whether it is a cloud or snow, you can simply click on the transit and you can see from which part is covering the snow part, where is the mid-high cloud, where is the surface. So surface to your mid cloud, mid high low cloud to completely your snow area can be very well analyzed with the spectral behavior and the help of RGBs. And then this is a thunderstorm. Basically, these are the signature of thunderstorm, cumulus cloud. Basically, it happens in the March, April, May. This is the pre-monsoon month, and you can see small cumulus cloud. These small spots of the white and off-white color. They within an hour or two, it will just now overshoot it and give the thunderstorm. And you see the whatever the brick color, this brick color represent the matured cloud. That means the thunderstorm had occurred. And the small part, particularly your the Maharashtra, your Konkan area, your Hyderabad, your Chhattisgarh, your Jharkhand, your Bengal, and your East UP, they are supposed to develop it. And now this helps us for our severe weather, particularly nowcasting for 2 to 3 years. And that is the reason that nowcasting last 3-4 years had been improve its accuracy from almost 55 to almost 70%. The only thing that you need to analyze it. Now, nighttime the RGB is also there because with nighttime we do not have a visible and SWIR. So detection of fire, low moisture boundaries, nighttime imageries can also be seen like this. So here also you can see nighttime, you can able to see the cirrus cloud, desert sand, low cloud, fog, medium cloud. So these all information. And now you can see the flow of dust also look like a pink. So because of the spectral signature or behavior of the particular channel, day and night time has been distinguished from the two different parts. Now, as I mentioned that how fog could be look alike. In a fog, all the imagery look simple like TIR1, TIR2, mid-IR, WE. But visible and SWIR has a particular way of how dense fog can be seen. One example I will give you. This is very useful for the weather forecaster, particularly the valley forecaster. Now you see TIR data on 4 UTC over the northwest region. The imagery can depict you that if you can see here, that is a valley fog. And valley fog could not be seen in a TIR. And visible also, valley fog could not be, although visible is a very well capture of your from your Pakistan to your northwest region, very well captured, but valley fog could not be captured. But here SWIR channel played a very important role. So is SWIR channel, if you can see, so SWIR visible and IR if you can combine, and then if you see the RGBs, you see entire, this is the area of Srinagar that very well captured, and then RGB if you can see clearly it is distinguished. So if you can see the reason, this is the snow, and this is the fog over the Srinagar valley, and this is the genetic visible. So my point is that the fog was one of the most important parameter, or you can say product, which we are delivering to the aviation sector. And now you can see exactly the same area fog from RGB it is seen. Now this is a during transition period, because this is most important. The flights are morning and 0 UTC, 3 UTC, because this is basically evening and morning, down and dusk period. There is a problem, but still this RGB has a sort of give you the indication that the how fog start dissipating in the NMP and start disappearing. They start appearing in DMP. So you see from the left to right, fog is disappearing, and then morning again it is appearing. So that basically it helps us for the weather forecasters or local forecaster of that particular region, which help us. Now this rapid, I'm not going to deep. This rapid tool is one of the best tools we have developed in consultation with Space Application Center. We thankful to Space Application Center. We have a, whatever I'm showing you, we have a features that we can analyze the pixel part, and we can see what kind of animation, RGB composition, contouring, change map background, base layer, all these things can be seen. Like in the imagery, you can see medium high level cloud, fog, and your snow can be seen. And these are the yeah. And then finally, I'm going a bit fast because I have to cover. So finally, we are giving to the satellite bulletin, and this bulletin in the form of where is the WD, where is the vortex, where is the lat long where supposed to be generated, where is the thunderstorms. All these things comes in the part of bulletin, and we are deriving it. We are disseminating it. One of the cases, if I can say, now you can see the dust. This is the month of April. The Arabia, because of the anticyclone circulation from the Arabia, a heavy, huge plump of dust is coming to the you can say you are Rajasthan region. This helps us because it is not it gives us the time for 3 to 7 days, 3 to 5 days. We can say the dust is supposed to come on Rajasthan or Northwest India. So it will affecting your many more parts of your local state and local region. So that can be, people can be aware. And from the research and scientific point of view, you can click on the thing and you can see that how dust can be seen from these imageries. And mostly dust will give you like from the scientific manner, I can say Visible will be around 21 to 25%. SWI will be always higher because there is no absorption, so 30 to 33%, and TIR will be more than 293. That means that is the warmer, that is not colder. So a higher temperature and higher SWI versus visible will give you the information about the visible, the dust particles. So this is also one part or the Arabia, that area, that dust can be seen from the RGB imageries, and you can analyze with the spectral channels behavioral aspect, and you can understand. Now this is the dust storm. This 13 March. It was in form of particulate matter, that is PM, across the Arabian Persian Gulf. Sentinel-3 has captured. It's very beautiful imagery. You can see left side, but you can see the right side. That is our inset RGB, and the most important part of it, left side is available in every 2 days, but here right side you are getting every 15 minutes. So what basically forecaster need is continuously monitoring. There is a monitoring of weather event at very high temporal resolution, and that's what the inset is helping us for whether our 2 days imagery is okay, but we cannot give what will happen in the next half an hour, 2 hours. So now casting has been improved like anything. Now this is the thunderstorm cases. I'll give very, if you can see Delhi, and if you can concentrate on Delhi and Chhattisgarh area, you will be finding out that thunderstorm was reported. This is the observation, and if you can see CTT imagery has started showing that which area will be thunderstorm supposed to be. So CTT is the cloud top temperature, is also one of the product which we are seeing at every 15 minutes to half hourly. So in 15 minutes to half hourly, we'll be able to generate these imageries to the forecaster. They are seeing this, and finally they are able to see which area. Now then their DMP, that is the daytime microphysics from RGB, also helping us along with CTT, and then this wind products. Wind is also the very much important while analyzing any chart or any satellite imagery, because what is the wind condition, what is the speed of wind. So this helps us to give the exact nature of which area, because now it is all the district is also giving this. So district-wise forecast has been improved from Delhi and Chhattisgarh. It was very well captured. Similarly, over 23rd May, Calcutta, it was also reported, and this was also successfully seen from our satellite imageries like CTT. If you can analyze, and OLR and those values you can analyze with wind and RGB imageries, and you will find out that ultimately from the radar also, if you can see higher reflectivity and these things, they give us the confidence limit. What I was showing you, the vast space technology, how we can improve the confidence limit. So these are the small inputs from the satellite image. These are the interpretation of satellite images that you need to put it. Now you see the Calcutta region and your radar, and then you see the DBZ. So combining spatial, temporal, and multispectral satellite imaging capability in the development of convection nowcasting product, this is the most important thing. And that is what I'm saying. IMD's nowcasting has improved like anything last 2 to 3 years. Now these are the another thunderstorm. If you can go by simply a satellite imagery, you click on the button, it will give you the how temperature is getting dipped. It is dipping to the less than 2 for 30K. That is almost minus 50 to minus 60K. So this time series plot is also helping us. Now, some of the things for the user from the trainee's point of view, how weather can be seen from the space. Like one of the most important things, the ITCZ, that's the intertropical convergence zone. They basically give the most. They are the basically trade winds, and this trade winds of southern hemisphere, northern hemisphere, both way it plays a major role because it generates often vigorous thunderstorm over the larger areas. So this is a kind of signature you can get it. Now this is the western disturbance. Basically, the western disturbance originating in the Mediterranean and in the area of the low pressure that brings sudden shower, snow, and fog in northwest India. So somebody are asking that how forecast will be improved. Yes, Mediterranean Sea, we are able to see that from the 6 to 7 days ago that yes, WD is supposed to be generated. So what will be the temperature? What will be the snow condition over the northwest India? That can be very well analyzed because of satellite, because of the closing monitoring of very satellite imagery at every 15 minutes of interval. These are the thunderstorms. So thunderstorm can also be seen like this, as I mentioned. And then monsoon depression. This is also most important kind of a phenomena during the monsoon month we are seeing. I think last year we have seen that only July month has covered entire monsoon period rainfall. It is because 6 to 7 monsoon depression has been generated. So 6 to 7 monsoon depression generated, and you can see how much rainfall it carries. It's the eyeball, you can say, it's important rain producing system of the monsoon period. So right from your Bay of Bengal, it moves from Jharkhand, it moves from Madhya Pradesh to Gujarat. Last year it happened. So entire July month has covered your monsoon rain. So analyzing this satellite imagery is also, again I'm saying, it's most important. It helps us that what could be the rain. So we can predict that over the Gujarat, over the East MP, over the West MP, over the northern part of Maharashtra, your Chhattisgarh will heavy to heavy rain to be supposed to be happen. And then these are the westerly trough. This is also very important. Now you can see over the water vapor imagery. So trough and ridge can be seen from the satellite imagery. So how best you can utilize from satellite data, because it is coming every hour, every 15 minutes. So if I can see in the past, these are the imagery can be, these are the analysis can be done once in a day. Now every 15 minutes you can do. So trough is a basically elongated area of the lower air pressure, and that bring the larger amount of vertical wind shear or the tropical disturbance and deep tropics. So that's the most important part. If you analyze satellite imagery in connection with your chart, you can be given a very good forecast, and it will definitely give you which are the area where induced thunderstorm activity is supposed to be happen. And now this is the jet stream. So how best jet stream can be seen with the high wind speed about 120 knots. So this is the jet stream, is basically a narrow band of fast moving air flowing from west to east. So northern hemisphere, it flows around 25 to 35 degree north. So this is also kind of information which gives the behavior of the winds. And this is monsoon month, it helps. So during the onset, it will be mostly over the northern side. So if I can say, northward movement is basically the best indication of the onset of monsoon. Now, as I mentioned, that if you can see the satellite imagery over from the IR point of view, or the Myanmar, that area, you are seeing just the satellite image. But from the microwave, as we have seen in the past presentation, that microwave has give you the signature. So since this is also one of the most important era of understanding the satellite imagery from the microwave channel point of view. And then recently, I think 3-4 years, we have one of the best thing we have started at IMD SatMet, that is improving the forecasting of accuracy for detection of severe weather. A rapid scan strategy we have started. So rapid scan is the kind of a international kind of a strategy where you can scan, deliver 5 minutes of scan over the particular region. So now we are able to scan our particular during the cyclone every 5 minutes. Now we are reducing. So if I can call long back from the 3 hourly imagery, we come to the 1 hourly, then we are coming the half an hourly, then we come to the staggering by 15 minutes of data, and now rapid scan is the 5 minutes of scan. So definitely it helps us. So this is the SOP we made in NSAT 3D, our rapid scan at New Delhi station, where we are evaluating which area need to be scanned, and then finally we give it to the MCF Hassan, ISRO, and then IMD's reception, and then disseminating to the forecaster, NWB models, decision makers, and government agencies. And now you can see here that 2 cyclones, Luban and Titli, can be very well. So every 5 minutes, genesis of the, or you can say low pressure area finding out from this particular imageries from the rapid scan help us a lot to understand what could be the best scenario in the future. Website also we have made from dedicated web page for available to the user. So user can also log into and they can get it. Like Luban and Titli, we have made it. Basically, what all these things we are doing, because we have a very international standard. We know that we have from the cyclone track and all these things and forecast, IMD is second to none. So basically, the world standard things have been developed for regional specialized meteorological center for tropical ocean over the North Indian region. Our prime responsibility is to see the weather bulletin and tropical cyclone advisories for benefit of the WMS Cape Panel region. So these are the input for tropical cyclone we are utilizing. Apart from microwave insert imageries, microwave imagery data, DWR data, ocean-set 2 wind, that also helping us a lot, NWP model guidance, and then finally decision making through the different of GIS layer and GIS plot. So now you can see how the inner core. Why I'm saying that rapid scan and this scanning help us to improve our tropical cyclone forecast and its location, because you see every 4th minute we will be able to see the inner core of where the eye is, when it will be crossing to the land, and how eye wall is behaving. So these are the kind of the improvement we noticed past 2-3 years from the different satellite data. This is the Ashoba, You can see, and this is scatterometric winds, and this is the animation. As I said, that dust. If you can see the imagery very well, see RGB, how RGB is helping us. That this dust along with the cloud is also coming toward here. Like your Jodhpur to entire your the northwest part Bhopal. Very well captured it in the May 2015. Now also from fog, Varda cyclone, from fog and cyclone, both are capturing very well. Now this is the cyclone part, and this is a Tibetan high. This is also very important during the monsoon month. So what we are looking at, that what will be the level of middle level moisture and higher moisture. So if we can see the circulation pattern is very well captured from the satellite derived wind. So this wind we are getting every hourly. So now if you can put it to the animation, you will be able to see where the anticyclonic circulation is being getting developed. So based on that, it will also help us to our local, or you can say the central weather agencies, to give what kind of a scenario in the monsoon, whether it is going to the monsoon bed, whether it is because if Tibetan climate is coming down, there will be heavy rain over your northeast state, or you can say your Jharkhand, your foothills Himalaya. But if it goes up, that means there is a break in a monsoon. So these are the signature what we are finding out from the daily satellite imageries. These are the western disturbance. You can see from the how WD are coming 3 to 5 days ago. We are able to see how these WD will be associated with the trough and heavy rainfall. And recently also we started INSET 3D BT with real-time lightning data. We merge it, and it also helps us because it also gives us the what kind of level of cloud is, whether this cloud is having any liquid water content, HRDS, or you can say any sort of this information will be updated at every minute. So we are putting into the satellite imagery and we are giving to the different stakeholders and users. So it is very well useful from our country. And GNS stations we have 25 GNSS. That is basically a kind of augmentation of this moisture data. You can say the GPS data, that is the total precipitable water. We are getting it. And then since we are moving fast and other countries are also doing well, IMD and ISRO is a very good partner since 1980, or you can say the earlier 70. So we're designing the new 4th generation of INSET series, particularly for the like ABI, AHI kind of, where 16 advanced imager will be there. Hyperspectral IR sounder will be all required. Lightning imager will be required. Radiation budget monitor is required, and the space weather and microwave radio. Now, why I'm putting this slide here? Because now we have to move on the taluka level forecast. People are demanding, as my initial talk was started with the increased demand from the NWP, putting pressure to the satellite data. Now, taluka level, if you would like to go to the forecast, you need some more hyperspectral nature of satellite data, and that will help us to give more accurate weather forecast. And then we need interpreter. As I mentioned, by seeing only satellite imagery, you can't able to understand unless you find where is a cyclonic circulation, where is the MTC, where is the overshooting top, where is the WD, and then you can make a very good forecast. So satellite imagery plays a very, very important role. I'm thankful to Mahapatra sir, our DGM, giving me the opportunity. Thankful to Space Application Center. Thankful to NWFC Satellite Division. And thankful to Dr. Prakash Chavan sir, giving me the opportunity. And then thankful to Hari Saab, Charuji. So if anybody wants, you can email me. And these are my regular tweets and LinkedIn. Anybody wants, they can post the question there. So thank you.